Hey everyone, welcome to my channel. Question we can find the value of x. Let's say log of x plus 2 with base 4 plus log of x minus 3 with base 4, which is equal to log of 4x with base 4. We have the same base here 4, here is again 4. On the right side of the equation we have 4. So our target solution, we must remember that log of x to base a plus log of y to base a is always expressed as what? Log of what? X times the product of x and y and with base. So because of this rule, this equation can be rewritten as log of what we have base 4, then x plus 2 is taken as x. That means y x shifts to what? Then x plus 2 times what? X minus 3. We can take x minus 3 as y. So x minus 3, then what? Our base is 4, which is equal to y, because on the right side of the equation we have 4x with base 4. So log of what? 4x with base. Then the second case is if you have the same bases on both sides of the equation, we must what? Take the exponents of on both sides of the equation. Why? Because for any logarithmic equation, log of x to base a, which is equal to log of y to base a with the same base a. That means we have base a here, and also again we have base a here. So we must take only what? X, which is equal to y. So because of this expression is again, we eliminate this 4 and 4, or then we take x plus 2 times x minus 3, which is equal to 4x. Great. Now we can easily find the value of x. That means x times x, we have what? X squared here. Then x times minus 3, we have what? Minus 3x. Again, x times 2, we have what? Positive 2x. Then 2 times negative 3, we have 6, which is equal to 4x. Great. Now x squared minus 3x plus 2x, we have what? Only negative x here. Then minus 6, which is equal to 4x. This 4x becomes on the left side of the equation. Then x squared minus x, again minus 4x minus 6, which is equal to 0. Yes, we can easily evaluate the value of x here. X squared minus 5x minus 6, which is equal to 0. In order to find the value of x, we must apply the quadratic, the general forms of the quadratic equation. Why? Because this is rewritten as ax squared plus bx plus c, which is equal to 0 4. So here a, which is equal to 1, b, which is equal to negative 5, but c, which is equal to again negative 6. Now we can find x, which is equal to minus what? B plus or minus under square root of b square minus 4ac, divided by twice of a. Great. Here that means a, b, c, then x becomes x, which is equal to minus of minus 5, yes, plus or minus under square root of minus 5 square, yes, minus 4 times what? What's the value of a here is 1, but c is negative 6. Great. The whole divided by 2 times 1. So x can be expressed as minus of minus 5 is 5 here, plus or minus 5 square is 25 minus yes, under square root of what? 25 plus what? 4 times 6 is 24, then divided by what? 2. Then x becomes x, which is equal to 5, yes, plus or minus under square root of 25 plus 24, we get 49. Great. divided by 2. Then 49 must be square root of 49 is expressed as here is under square root of what? 7 times 7. This is again under square root of 7 square. So this radical sign is cancelled out by here. Then we get only 7. So x, which is equal to 5 plus or minus 7 divided by 2. Then x1, which is equal to, yes, 5 plus 7 over 2. That means 12 divided by 2, which is 6. 6. Again, x2, which is equal to, when I take the negative side, 5 minus 7 divided by 2, which is negative 3 over 2. But here, we must remember that the domain of this equation must be, yes, the first one is x plus 2 greater than 0 here, and also x minus 3 must be greater than 0, and 4x must be greater than 0. Now, x greater than 0 means here we get x must be greater than negative 2, and also here x must be greater than 3, positive 3, x must be greater than 0. Then the intersection of this expression must be x greater than 3. X must be greater than 3. So the solution set of x must be greater than 3. So because of this, 6 must be the solution of this equation, but x2 result 5 minus 7 over 2 minus 3 over 2 is not the solution set of this equation. We can take x, which is equal to 6 here. So we substitute log of, yes, log of here. The value of x is, yes, 6 plus what? 2. Then again with base 4. But the value of x is, sorry, log of 6 minus, yes, 3 with base 4, which is equal to, here is also log of what? 4. What's the value of x, which is 6 with base 4. Now we have here log of what? 8 with base 4 plus, but here we have log of what? Yes, 3. Why? Because 6 minus 3 is 3. 3 with base 4, which is equal to log of 4 times 6 is, we have log of what? 424 with base 4. Now we can apply what? The product rule of, yes, the product rules of what? Logarithmic property. That means you have here log of 8, yes, times 3 with base 4. Then from the right we have log of what? Yes, 24 here with base 2, 24 with base 4. Now this is 8 times 3. We have log of 24 with base 4, which is equal to log of 24 with base 4. This is correct. So the value of x must be 6 is the solution set of this equation, but x, which is equal to minus 3 over 2, is not the solution set of this equation. Great.